Welcome back, students. We are in lesson 13. Let's talk about some secants and circles and tangents and chords today. So when we have two intersecting lines, we know that the opposite angles, or what we call the vertical angles, are going to be congruent to one another, right? We know that. The fact that it has a circle around that intersection does not change that fact. These are still just two intersecting lines, and they still have that vertical angle quality. So both of these degrees of measure are the same. Now, if the intersecting point was in the center of the circle, then we know that the intercepted arcs here would be the same degree of measure. But because the intersected point is not in the center of the circle, we have two different measures of intercepted arcs. So how do we find the degree of measure given just the intercepted arc degree? There is a very easy formula, and we use this for the degree of the interior angle of intercepted arc. So what we do is we're going to add both of these degrees, these together, and that is when it crosses on the inside. When the secants cross, I don't want that to be taken as x. So let's say when the secants cross inside, only when the point of intersection is on the inside of the circle, we're going to add. So we're going to say 40 plus 80 divided by 2. That's going to be 120 divided by 2. That would be 60. So x would equal 60 degrees because it's this and this added together. So if you can remember, here's the way I like to look at it. The intersection on the inside of the circle, that looks like a plus sign. Right? It's a plus sign. So that reminds me, inside the circle, it's a plus sign. Because when they intersect inside the circle, it looks like a plus sign, right? That X or that cross looks like a plus sign. So when it's inside the circle, we add. When the intersection of those secants is on the outside of the circle, let's see if I can draw a circle here. Let's say we have a secant here, and we have a secant here. When it is on the outside, the secants cross on the outside. Here we add, here we subtract. Those are the only two rules that you need to know. If it's on the inside, it is plus. If it's on the outside, it's minus. And if you look, the chord on the inside, they don't cross, so they look like little minus signs. You got a minus sign here and a minus sign here. So if that reminds you of the process, use that trick to remind you, okay, it's just a line segment, so it looks like a minus sign. So we are going to do the opposite. It's the same process, we just do the opposite operation here. So we would take whatever this is and whatever this is, and we would subtract the smaller from the larger, and that would be x here. This would also be x because these are still vertical angles and they still have the same degree of measure. So let's say that this one is 20 and this one is 60 degrees, just for funsies. So then we would say 60 minus 20 divided by 2. Notice the only thing that changed is the operation because of where it's located, where the intersection is located. So 60 minus 20 would be 40. 40 divided by 2 would be 20. Right? So 20 degrees would be the measure of this x. X would equal 20 degrees. Okay? Easy peasy. All right? So 20 degrees would be the measure there. for x. Let me put it here so you can actually read it. 20 degrees is the value of x. All right, so that's not so hard to remember, right? That's pretty straightforward. So something I want to draw your attention to, because it is something that's going to happen in one of your practice problems later on. If you can find the angle here, right? We know this is 60 degrees, then that allows us to find the angle here. I wanted to remind you of the straight angle quality of this line. And because, let's call this P, because P plus X, so P plus X would equal 180 because it's a straight angle. P plus 60 would equal 180. So that means that P is equal to 120. So you could find the degree of measure for these two angles because they too are congruent because they're vertical angles to one another. And because this is a straight angle, if you can find the degree of measure here, then you can find the degree of measure here and here as well. So don't forget about the straight angle quality of the secant. It does measure 180 from side to side there. So don't forget you can add them together and get 180 to find P's degree of measure. All right, so let's look at what if one of those secants isn't a secant? What if it's a tangent? And it, note that you can't have a secant and a tangent cross inside of the circle. The very nature of a tangent means it has to be on the outside, right? So if you've gotten all this written down, I'm going to clear the page. And let's look at a secant and a tangent and how that works. So here's my circle. Come on, do a circle. There we go. Let's see. Here's my tangent. I'm going to draw a tangent here. Here's a tangent. It just touches the outer edge of the circle there. And I am going to do, let's see, I want to get 120, so that'd be about right there. All right, so here's the point, and here's the point. So this is, we have three arcs here. We have a small arc, a medium arc, and a major arc. This arc is 120. This arc is 60. So by definition, by default, that means that this arc is 180. If this is 60 and 120, then this one is 180. So if we have two called out for us, we can find the degree measure of the external arc here, of the rest of the circle. So now we need to find out what x is. What is x? X is going to be the same thing as when we have a intersection on the outside. It's the same thing. The only thing different is instead of having the two arcs specific to the inside here, one of them's just, we only, instead of 4, we only have 2, or we only have 3, right? And because we have these two called out, we can accurately define the third arc, right? Before, when we had the circle and it crossed on the outside here, we knew what this one was, we knew what this one was, and we knew that this one, we'll say Y and Z added together, had to be the difference between 360 and these two, but we didn't know how much was each one, we just knew the sum. Well, now that they're both in one arc here, because instead of 1, 2, 3, 4 arcs, we have 1, 2, 3 arcs, we can add these two together, subtract it from 360, and we know what the third arc is. That's the only difference. That's when you have a tangent and a secant instead of two secants. Okay? So I'm going to erase this. That was just for illustration purposes. So how can we find x? Same exact process. We say 120 minus 60 divided by 2. That's going to be 60 divided by 2. That's going to equal 30 degrees. So x is equal to 30 degrees. So if this is 30 degrees, this again, This is a straight angle. It's a straight line. If this is 30, then this has to be 150, and this has to be 150, right? So now we have all of the degrees of measure formed by the secant and the tangent. And we also have the arc here, 180. So we have all of that cool information about that. Now what if we have two tangents? How does that work? If we have two tangents, let me draw one here. That is not a circle. I got to get better at drawing circles. Let me draw a circle here. There we go. All right, so if I have a circle here, I'm going to draw two tangents. All right, I'm going to draw to a point out here somewhere. Let's see where it intersects. All right, so here's my intersection point here. Now we know by default that these are going to be the same length because that's just the way a tangent around two tangents around a circle works. These are going to be congruent to one another. But instead of having 3 arcs, we only have 2 because we have a point of intersection here and a point of intersection here where the tangent touches the circle. So that means we have a major arc and a minor arc, and that's all we have. So if we are given one of these arcs, we can find the other. So for instance, let's say this one is 130. Let me go back to my pen. This is 130 right here. That's what that arc is. So by definition, and this is x, this is x, this is p, and this is p. So if we want to find x and p here, all we need is the degree of measure of one of the arcs. That's it. We can say that, first of all, 360 minus 130, that's going to leave 230. So this arc has to be 230. Now we have the two arcs. We have the bigger arc and the littler arc, the major and the minor. So now we're going to take that and we are going to say 230 minus 130. It is the same formula. If it crosses outside, it doesn't matter if it's secants or tangents. If it's outside, it is going to be subtraction. So 230 minus 130 divided by 2, that's going to be 100 divided by 2 is 50 degrees. So x is going to be 50 degrees. This is 50 degrees over here. So what is p? 180 minus 50, p is equal to 130 degrees. So we can find all of that information just by being given the one arc degree. All right, so easy peasy. You guys can do this without any problem whatsoever. And that's all we have for secants and tangents and degrees of measure and arcs and so forth and so on. So really, if you have two tangents, it's really easy to get everything. If you have a tangent and a secant, you have to have both arcs in order to find the degree of measure here, right? If you have two secants, you have to have both arcs in order to find the degree of measure here. All right, so let us move on to the products of chord segments. Let me clear the page. So before I move on to products of chord segments, I'm just going to summarize. If the secants cross inside, it's x minus y divided by 2. Or actually, I'm going to change that to big minus little, big arc minus little arc divided by 2. That equals the vertical, or that equals the measure of angle x. All right, if it crosses outside, that includes tangents, then it's going to be big arc, inside is plus, outside is minus, little arc divided by 2 equals the measure of angle x, the vertical angle that corresponds to those arcs. Okay? That is it. Those are the two things that you need to remember. If it crosses inside, it's plus. If it crosses outside, it's minus. And that includes tangents. Those are the only things that you need to pull from all of that. So now I can clear the page and we can go on to talking about the products of chord segments. So we have a circle. Yes, we're still on circles. And we have two chords. We talked about this before in a previous lesson. If we have two chords that intersect inside of a circle, and let's give them, this would be 3, this would be 8, this would be 4, and this would be 6. Always, 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 the way circles work, the product of these two are going to equal the product of these two. So if you don't have one of these dimensions, let's say this is x, then you could easily say 3 times 8 is equal to 4x, right? 24 is equal to 4x. X is equal to 4. So this would be, 6. So this would be 6. That's how you would find the missing length of a part of a chord. You've got to be given 3 in order to find the one unknown, just like any other equation. You can't solve for 2 unknowns unless you have some type of substitution or elimination process that you can do, that you can use. So you have to be given more information. But when you just have these 4 things, you can only have one of them that's unknown. All right, so that is how you find that. That's how you find an unknown chord length or chord segment length. But there's another thing that you need to know. Let me draw me a circle here. What if the intersection of the chords, what if you have secants instead, and the intersection is on the outside? How does that work? So let's say we have another secant here, and it does this, and then it does this. It jumped. It's not supposed to do that. Let's have it go right to there. All right, so if we have a situation like this, when we have two secants that cross outside or that intersect outside into an angle, if we have the dimension of these secants here, this is 10, whatever this is here is going to equal, whatever these are, they equal each other into a specific relationship, and that relationship is going to be the segment closest to the point of intersection times the sum of both sections is equal one to the other. So what I mean by that is 3 times 3 plus 5 is going to be equal to 2 times 2 plus 10. Always, always, always. And that would be how you would find missing lengths of chords and secants. So that would be 3 times 8 is 24. 2 times 12 is 24. So if this was x, and keep in mind this is just an illustration, this is not the actual measurement of these lines, it's just a rendering to give you an illustration. If I had a missing information here, let's say I had a missing x here, I could say 3 times 3 plus 5 is equal to 2 times 2 plus x, right? And then you would say 3 times 8 is 24, and that's equal to 4 plus 2x. Then you would subtract 4 from both sides. That'd leave 20 is equal to 2x. Divide both sides by 2, and the value of x would be found to be 10, which was what it was to start with. So that is how we would apply that information there. And it's always the external segment times the sum of the segments. The sum is equal to, for this would be secant 1 is equal to secant 2, the external times the sum. That would be your formula for that. And I would be sure to draw that or put that with the illustration here so that you can apply that. All right, and I believe that is all that we have. Yep, that is it. That is all that we have for secants and chords and tangents and angles and lengths of those as well. So I will see you all in lesson 14. If you have any questions, please feel free to message me. I'm more than happy to help.